Hey everybody, Mr. Skelton here, back at Lesson 7, Unit 6, and today we are going to be focusing on one concept and one concept only, and that is going to be the law of sines. And we're going to be finding two things. We're going to be finding sides, and we're going to be finding angles. And so a couple of just quick reminders for you. Law of sines. Law of sines is something you actually did in geometry, so hopefully you can recall this. If you can't, no big deal, but hopefully this jogs your memory a little bit. We're going to be finding two things. We're going to be finding sides and we're going to be finding angles. And the one thing I want to remind you right away is whenever you're finding angles, right, we always want to use inverse sine, inverse cosine, or inverse tangent, even though we're not probably going to be using that today, but sine and cos, make sure we're using inverse. And we'll go over that when we get to that, those type of problems, okay? So this is a formula. So the law of sines is a formula, all right? And I'm going to actually show you how we get it instead of just giving you the formula, because I think that's important, especially in honors class, to figure out where things came from. So this is a different way of finding the area of a triangle. Let's say you have 65 degrees here. This is 7, this is 10. What I want you to notice also, this is A, B, and C. We use capital letters to name the vertices of a triangle, so capital A, capital B, capital C. And then the side opposite of the capital letter is the lowercase of the same letter. So side C is opposite angle C. Side A is opposite angle A. Side B, lowercase b, is opposite big B. All right, that's going to be common when we get throughout these next two lessons. Okay, so let's get right into it. That's the area formula of a triangle, right? 1/2 base times height. So when we look at this, we don't have a right triangle. This is a non-right triangle problem. We draw an H, which is the altitude. When we draw in an altitude, that's 90. And what I'm trying to do here with these two equations is, with this equation right here, H equals A times sine of C, what I'm trying to get to is this. I want to find this height, because if I can find the height, right, then I can plug it back in here. So if I go opposite, all right, over hypotenuse, so H over 7, I get the sine of C, which is opposite over hypotenuse, which would be this right here, right? Sine of C equals H over A. A is 7. I didn't put the numbers in. And if I solve this for H, so if I solve this for H, H times 1 would be H. Sine of C times A is going to be sine of C times A, which is this. And then we plug this. Since H equals that, use substitution, and we plug it in there, and we get A equals 1/2 B, which is base, times A times sine of C, okay? And so this gives us A equals 1/2. We usually write it as AB times the sine of C, okay? And so basically what that means is, if you have the angle and the two included sides, so if I redraw this real quick, by the way, this is not law of sines. This is just an area formula, a different area formula, not law of sines. Okay, this is just how to find a different way to find the area of a triangle. You also learned this in geometry. So basically what this is saying, this is the formula. Basically what this is saying is, if you have an angle like 65 degrees and you have the two sides that are included in between the angle, you would write this area as area equals 1/2. A and B stands for the sides, so 7 times 10 times the sine of the included angle, which would be 65. And then we would just take our calculator, okay, and we would calculate this out. So we would just go 0.5 times 7 times 10. I always like to hit equals after that, and then times that by the sine of 65. Again, if you're using a graphing calculator, make sure you're in degree mode, so the area of this triangle would be 31.7. Okay? All right. So this formula is what you would use to find the area of a triangle if you have the angle and the two sides that come together and include that angle. That's what that formula would be. Okay? All right, let's turn the page here. So now I'm going to show you the law of sines. So this right here is going to be the law of sines. And this is really the gist of what we're going to be covering today. Now I know this is kind of hard to see, but this is big A. Opposite of it is little a. This is big B up top, little b here, big C, little c. Okay? And what we're going to do is I'm going to draw in an altitude, and I'm going to call it x. Now, what I want you to understand right off the bat is what I'm doing. This is the law of sines right here. It's basically, I'll explain what it is. It's the sine of the angle over its opposite side. Sine equals the sine of an angle over its opposite side, sine of the angle. Now you're only going to use two of these, okay? You're only going to set up a proportion, but all three sides are proportional with the law of sines, but we're just going to use two instead of proportion. So this is what law of sines is. I'm going to show you how we get there, okay? Real quick. And again, notice it's C over C, A over A, B over B, so it's the angle over its side. So here's how this would work. If I wanted to find or express the sine of A, what would the sine of A be? Be opposite over the hypotenuse. If this is 90, then this is 90, so it would be equals x over C for this triangle right here. If I wanted to express C, the sine of C would equal x over A, opposite x over hypotenuse A. Now, I'm going to solve both of these for x. Solve both of these for x. And again, what I'm doing right now is deriving this formula. I'm showing you how we use this formula, even though this is really all you need to know. So I'd get x equals sine of A times C, and over here I'd get x equals sine of C times A. Now, using substitution, I'm just going to, since these are both equal to x, I'm going to set them equal to each other. So sine of A times C equals sine of C times A. Now, this gets a little tricky, but I'm going to divide by C on both sides. So I'll get sine of A equals the sine of C times A over little c. And then to get rid of this little a, I'm going to times this by 1 over A on both sides. Whatever you do to one side, you have to do to the other. Those a's would cancel out, and I would have to multiply this, and I would end up getting the sine of A, big A, over little a, because that would be on the bottom, equaling the sine of big C over little c. And that is how you get the law of sines. That's the proof of how you get law of sines. Okay? So, how do we apply this to problems? Let's do it. So, usually if I have a problem like this, what I'm looking for is an angle with its opposite side. Okay? So like I see 15 and opposite of that is 7.5. I need to find x. So these are going to go together, right? So I would go the sine, it's always the sine because it's the law of sine, sine of 15 over 7.5. That's the whole gist of the formula, is it's the sine of the angle over its opposite side. Okay? So I have the sine of 15 over 7.5 equals the sine of, now I need to know what this angle is because it's going to go with x over x. So it's the angle over side, it's the angle over side. Now what is that angle? Well, we can find it, right? We can go 15 plus 20 equals, and subtract that from 180, and I'm going to get 145. So that's 145. And then it just turns into cross multiplication. So you're going to have the sine of 15 times x equals the sine of 145 times 7.5. And this just becomes calculator work. So I'm going to do this part on the right first. So the sine of 145 times it by 7.5, it equals. And then I know I'm just going to divide that by the sine of 15 to solve for x, right? Because I'm going to get x equals, and then I'm going to divide that by the sine of 15. And so I get 16.62. So 16.62 would be my answer for x. So that's finding the side. Okay? Flip it over. It says use the law of sines to find the value of a. So here's a right here. So it's the same kind of situation. Here's your triangle. So there's my angle. There's the opposite side a. So I know I'm going to have the sine of 35 over a equals. Now, I have this 20 here. I need to know what this angle is. So it's almost the same situation we just did. So I can go 15 plus 35, subtract that from 180. You should get 130. So this is 130. So then it's this angle with 20, so it's the sine of 130 over 20. And that's the setup. Cross multiply again. So you're basically going to take the sine of 35, I'll show you my calculator here, sine of 35 times that by 20. Make sure you put the parentheses around there. And then I'm going to divide that by the sine of 130. And I should get A equals 14.97. 14.97. Okay? Now, those first two examples, we found side lengths. Now we're going to find the measure of an angle. So this gets a little tricky because you just have to remember now we're going to be using inverse sine to find our angle. The nice thing is it's the same setup. Okay? So that's nice. We're just going to look for that same kind of pattern. There's my angle, there's my side opposite. So sine of 35 over 6 equals. Now I got to find B. So here's B. I got to find out what that is. Its opposite side is 8. So I'm just going to call it sine of x degrees. You can call it B. I should put B there, but x, whatever, that's what I want to find, over 8. Now cross multiply this. I'm going to draw this out. So I got the sine of x degrees times 6 equaling, I'm just going to get that number. So sine of 35 times 8. Now I get this big long decimal, and that's going to go here, right? But I don't want to round this. I want to round at the very end, or I want to make sure I have an exact answer. So don't make this 4.5 or 4.6. That answer right there is when I cross multiply the sine of 35 times 8. Now, how do I solve for x? Well, I got to divide that by 6, right? So I'm going to go divide it by 6, hit equals. And so now I have this sine of x degrees equals this decimal 0.7647. Again, keep that in your calculator. Now, how do we solve for x? How do I get rid of sine? You can inverse both sides, right? So the sine inverse and sine cross out, you're left with x degrees. So I got to do second sine of this answer. So second sine, second answer equals. So my x is 49.8 degrees. And that's how you find the angle measure. Okay? And that's it. So again, that's a review for us. We did 2 examples where we found sides, and that last example is where we find angles. And again, we're just using the law of sines, which again is pretty basic. You learned it in geometry, but hopefully that was helpful to recall some of that information. As always, look forward to answering your questions in class, and I'll see you then.